let's say the average here is 65 and the final average turns out to be, let's say 52. And the higher it is, let's say this one here, test 1, test 2 average 87. And this guy here is, let's say 92. Okay, now the thing is, of course, different people give different results, but there's a trend between what you get at the beginning of the class, the first half of the class, test 1, test 2, and how we can use that to predict what your final, your grade at the end, if we've given the situation. So given test 1, test 2 average, can we predict the final average at the end of the semester? Of course, again, we deal with individuality here. So yeah, there are a lot of people taking test 1 and test 2. And then these people who actually still follow the class till the end of the class get their final average, right? Now, then, of course, different people may come up with different results. Like for example, these two individuals here, they start with different, very close test 1 and test 2. Let's say they get 58 and 59, let's say. But one of them average 51 at the end, and the other one is average, let's say 70, let's say 63 at the end. Okay. Now, of course, yes, but Thomas, everything can happen. That's true. But even though we say everything can happen, there's not much different. Can you say for those people who get 40s at the beginning, you don't expect them to average 90 at the end. And those people who average in test 1, test 2 average 80s, you don't expect them to suddenly average 25 at the end. So there's what we call, quote unquote, some relationship, even though, of course, different people come up with different results, but there's a trend. There's a trend that we can use. And this is actually what I used in the past to tell somebody, hey, you know what, your average in test 1, test 2 is too low. If I were you, I'd drop the class or transfer to another teacher. And that's usually quite early in the semester. As I know, my test 2 usually week number 8. And yeah, most of the time they don't want you to transfer, but at least you know good enough that to drop the class and then fight for your other classes. Now, I'm not a big fan of somebody dropping class, don't get me wrong. But I also know that sometimes you have so many things in your plate that I don't want you to actually fight so hard for my class and you end up failing all your other classes too. You know, that's not a good plan. So pick your battle, okay? Pick your battle. That's why sometimes I tell them, you know what, maybe you just don't focus yet. It's not a good idea for you to go on with my class with this kind of initial situation. Well, anyway, so of course, some students say, but Thomas, even though my average is, let's say 60 in my test 1 and test 2, the average is 60, but what if, they say, what if I suddenly study really hard and at the end, I get perfect score in my test 3, test 4, and my final. Is it possible? Yes, it is possible. But how likely it is? The probability is very small. Okay, so there are a lot of unexplained things here why it actually make deviation from the blue line, right? Okay, but the method I show you later on, I basically don't show you method. I show you the procedure, how to use your calculator and how to use Excel. But I will also show you the formula. You will not use the formula though, but at least you know what the formula looks like and how complicated it is to use them. Now, so what we are going to do is this. We will start with the data. It will be a pair of data coming from the past. So this will be past data. Okay, and the result we expect is what we call regression line. That's regression line. Okay, now the thing is, we also need to find out how strong is the regression line that we have. In other words, if the result, the strength of the result, the strength of that regression line is low, then we know that the regression line is not as accurate in predicting the trend. Okay, now let me show you my old the result from my test for my last semester. But I need to cut and paste them. Give me a second. Okay, this is the result from my last semester. This is the result from my last semester, and what I'm going to do is, like what I said earlier, I will just use my test 1, test 2 to predict the result of the final. So let me change this to only 2 decimal places so that it doesn't scare us too much. Okay. Now, so what can we say about our test 1, our final at the end of the semester, what these people get with us knowing their first and second test. Let me get the average of test 1, test 2 first here. So average of test 1, test 2 equal to this guy plus this guy. The first person divided by 2. The first person here actually have something happen to her toward the end of the semester. So her test 4 and final just suddenly doing really bad, as I remember. I don't remember precisely. Let me see that. Okay, so this is the average of test 1, test 2. Okay, and this is the end of semester average. Okay, now, and I want to show you how our knowing test 1, test 2 enable us to see what happened, the result at the end. Now, let's first see what we call the scatter point. I will plot this. Don't worry. I know you won't use I know you won't use Excel in your final later on. But I want to explain to you first what are we going to do and where we start. So we start from this 2-column data. This data here is independent variable, and the one here is dependent variable. The one being predicted. So this is we can say this is the predictor, or to be more precise, the candidate we use to predict. Okay, and this is the predicted, I should say. Okay, not prediction. The prediction is something else. Of course, we don't know yet if test 1, test 2 is a good indicator of what a student will get at the end of the semester, right? Okay, but that's what we try to do. That's the strength of the linear regression that we see later on. But you see something very clear. somebody who averaged, for example, 0.5 in the first two tests. So yes, somebody gets 1 in my test 1 and somebody gets 0 in my test 2. Yes. Okay, and strangely, this person actually stay until the end of the semester. Okay, I don't ask me why. I don't know. I don't know. Okay, I don't know why. But then with 0.5 average from test 1, test 2, you don't expect that person to pass the class. I mean, cut my fingers. I give you all my 20 fingers. Right? What happened if that person doing very, very well, Thomas, in test 2, in test 3, test 4, and final? Well, there's a chance that person can pass, but how likely it is, you know, right? Okay. Now, the thing is, let me first create what we call scatter point. What I do is, well, you learn Excel a little bit, right? What I do is I go to insert and then click this one here, the scatter. Boom. So that's the scatter plot graph. Okay, so you see the numbers at the bottom here represent your X component. Usually that's the first. Usually that's the first column, and the Y component here is usually the second column. Of course, you can change that ordering. Okay, so this is the scatter plot. Now, what is our regression line? Regression line is the line that we use to find the line that fit this graph best. Maybe give me a second. I cannot write on that, that's the thing. So let me copy this, and then put it on download. Okay, so what we try to do now is to try to find the line that best fit this picture. Now, it may be this one, right? But maybe also this one. So how do we know, Thomas, which one is the best? How do we know which line is the best line? How do we know which line is the best line? Well, we need to decide what is the indicator to have the best line. And the best line will be, black color, the best fit line is the line that gives least error. To be more precise, least square error. Okay, Thomas, what is least square error? This thing. Least square error is the following. Suppose this is the line. Suppose this is the line. Now then, the square, the error refers to the difference with the vertical difference. The vertical difference. That's the error. Now, for each error that you get, you take the square, okay, and then you add. Okay, let's say we do the least square error for this line, compared to if I do, for example, this line. I know that's a lot of line here. Okay, compared to this, and then I see how about the error. Let me use green. Okay, the error for this, the error for this, the error for this, for this, for this, for this, like that, right? Okay, and you square all those errors and then add them. Now, whoever get the lesser sum, that's a better fit. Okay, now later on I will show you the formula to get the least square errors line. Okay, the best fit line. Now, What I will do now is just use technology for now. Just use technology to get that line. Okay. Now, first, what will be the best line? The best line will be done in the following way. Honestly, I don't remember. Let me see. Not this. I think I need to. Oh, I cannot play from here. I need to go back to my Excel. Go back to my Excel. Yeah, try to do it from there. Now, in this Excel here, I use a fake version of Excel though, the cheap one. You see the WPS Office, okay? Not really the Microsoft Office, okay? Now then, this is actually free. But if you go to Excel, you can actually find out. You go to YouTube and find out. You type linear regression. Then what I will do is I will get the trend line. Now this is the line that gives us the least square error. Okay, that's the best fit line. I set it at the linear. Okay, now then, if I want to find the equation of that regression line is, I then display even the R squared value. Okay, I wonder if I can enlarge that. Well, anyway, let me copy that again and put it in our node. Talk about that from there. Okay, from here I can enlarge. Okay, now this line here, this equation here, is what we call the equation of the regression line. The equation of this line here. Okay, that's supposed to be y hat. The notation is supposed to be y hat equals to 0.8966x minus 4.5628. Okay, now what is this y hat? This y hat represents prediction. That represents prediction. Remember, this is our predictor. And the y earlier is predicted. That's the actual data, actual result. Okay, now suppose for example, I pick, let's say, which one is good? Let's say this guy here. Okay, the average, for example, our x, which is the average of the test 1, test 2, is 42.25. The actual result at the end of the semester is 24.41. That's the actual result. Okay, but of course, after that person took test 1, test 2, but before the final, I don't know this thing. This thing is unknown. I don't know this thing. Okay, but can I use this x here? Can I use this x here to predict that y? Now then, what I do is I use this formula. But this formula here, this y hat, is only prediction. Okay, so if I put 0.8966 times 8966 times 42.25 minus 4.5628, what can I say about the average at the end of the semester using this number. So I use my calculator, 0.8966 times 42.25 minus 4.5628. According to the number, I get 33.31855. Now, but Thomas, you see at the end that person get less than that. Well, it can be less, it can be more. After all, this is prediction. Okay, this is prediction. But we don't expect that to be super accurate, that like this y had to be 24, but it gives us a pretty rough feeling that, you know what, if the prediction is 33, I don't expect that the actual result suddenly becomes 60, you know. Okay, now you can try another one. Let's say I pick which one? 47.5, 22.75. 47.5 at 47.5, right? Suppose I plug that into my y prime, 0.8966 times 47.5 minus 4.5628. I get y hat to be 38.0257. And then if that person say, but Thomas, you know, that's your prediction, right? Using my test one, test two, but you don't know how I will do in my test three, in my test four, in my final. Yeah, I don't know. Nobody knows. Even the person who took those tests didn't know. Okay, but using the data I have from the past, I say, well, you will get, the prediction will be that you get 38. Will that be more, possibly more? Yes. Possibly less? Yes. In fact, then that person keep on going with the class, that person get the final average at the end is 22 something. 22.78. But Thomas, you see, it's still very far though. Yeah, okay, I agree. That's actually further than the error here, the error of the prediction. This is the error I talked about earlier. The error here is actually big, right? But strangely, in these both cases, my prediction is still higher. Yeah, strangely, in both cases, my prediction is still higher. Of course, there are cases later on I can easily find other x that give me uh, the y that is higher than my prediction. Okay, I think this object, this person here, 93.5. So when x equals to 93.5, let's see what happened with the prediction and compare that with what that person gets at the end. So 0.8966, 93.5 minus 4.5628. I get 79. According to this data. And in actuality, that person actually end up with 95.23. Okay, so it is also not correct to say that my prediction will always be overestimate or always be underestimate. No, the way this model being set up is that it will kind of balance them out. Okay, it will balance them out such that the error we get in overall situation is the minimum possible error if we see from the square point of view. Basically, the further you are from the line, the more I penalize you. That's how we get we use the square error. Okay, these are the error here. So which one is so the first two cases, like this case here, let's call this case A. Let's call this case A, and this is the error. This is the error here. Okay, for case B, this is the error. And for that case that we have the last one, this is the error. Okay. Now the thing is the model is reliable? Of course, earlier we saw the trend, right?
Thomas, are you writing on your notes? Because I can only see your Excel window.
Oh shoot! Oh shoot! Yeah, I'm here. I'm writing it here. Okay, let me ask you to copy that down if you want to. Yeah, but basically when I pick an X that we have earlier, like one of the data we have up here, right? Okay, one of the data we have up there. The first case I chose was when X equals to 42.5. When X equals to 42.5, I use this linear regression equation, and I get this is the prediction, the Y hat. Now, of course, when we took only test one and test two, we don't know what that person will get at the end, right? We don't know what that person will get at the end. But using our prediction here, we can more or less tell, you know what, your Y hat at the end of the semester, your average will be around 33, maybe more, maybe less, but this is 33 is way too less compared to 68, the passing grade, the passing score, right? Okay, so I will tell that person, you know what, consider dropping the class. But then this person said, well, Thomas, you don't know how I will do in my test 3 and test 4 and final. Yes, nobody do. Nobody does. Okay, nobody knows what this person will get in test 3, test 4, or final, including that person himself or herself. Okay, because it will happen in the future with that time reference. Okay, then after we wait, at the end of the semester, that person gets 24. Okay, which is even less than what we estimate. Okay, and I pick the second case when X is 47.5. When X is 47.5, after test 2, I use this regression line and I predict, oh, you know what, this is what I get. This is what I get. And at the end of the semester, this is what. Okay, now then I pick the third case. Okay, according to the prediction, that person is supposed to get 79 something, and it turns out that person end up with 95 something percent. Okay, so sometimes my prediction is overestimating, sometimes it is underestimating. Okay, the way the computation being done, the way the procedure being set up, guarantees that we will have enough errors, enough overestimate and underestimate that balance out from the squared point of view. Okay, now the thing is, how do we know what is the strength of this linear regression? We will look at the strength of this linear regression. We look at the R. Where's that R, Thomas? Here. The R is from here, okay? From that R. Now, what we saw there is R squared. Now, R squared represent the portion is represent the portion, the explained portion of y by x. How to say it better? It's like the up and down of x tells about the up and down of y by r squared. If we look at this number here, let me write it down, 8725. In this case, r squared equals to 0.8725. This means that, quote unquote, not perfectly correct, okay? It means like 87.25% of the result, the prediction we get earlier, okay, explain the actual result. Okay, now then, the strength of this regression is the square root of that. How strong is that? Then you take the square root of this number. Okay, it's supposed to be plus minus though. It's plus if the coefficient is positive, if the slope is positive, the R is negative if the slope is negative. Okay, now if I take the square root of that number, 0.8725, I get 0.93408. Usually, if the R is, this is my personal use, okay? Though not, I supposed to go through some hypothesis testing for this, but my own use, if the absolute value of R is greater than 90%, then the regression line is a good predictor. Okay, but more details later on though, if I have time. Okay, what I'm about to do right now is to teach you how to use calculator to find the regression line, okay, the equation of this regression line, and how strong it is, the R squared and R. Okay, now let me ask you to copy this number down. These two columns here, these two columns. Okay, I will key them in, but let me make sure that I empty my column already. Let's see. So my column 1 and column 2 is occupied by some other numbers. Let me clean them up first. I don't know if you remember how to clean them up. Okay, this is how we cleaned it up. Okay, we go to stat and then choose clear list, or list 1 and list 2 earlier. Okay, so now then you need to go on which list you want to clear. I want to clear list 1 and list 2. Now list 1 is here. You see that? Above 1. The second of 1 and list 2 is the second of 2. So I will clear list 1, second 1, that gives me L1, comma, second 2, that gives me L2, enter. So that's how I clear it. Okay, I go check again, go to stats. So they clear it already. Now then, my list 1, I will key in those, the one in the first column. Okay, I hope you can do this together with me though. Okay? Hands-on experience. So the first one is 75.75. The second guy gets 82 on the average of test 1, test 2. The third person 0.4. And the fourth person is 47.5. 93.5. 7.75. 0.5. 90.5. 5.5. 42.5. And then I go on to the second column. The person who gets 75.75 in his or her test 1 on average end up with 40.88 at the end of the semester. The second person, 82.5. The third person, 12.93. The fourth person, 22.78. And then the highest person is 95.23. 3.85. 3.71. 79.37. 9.45. And 4.41. Okay, now make sure that at the end you get the same number of data. Okay, if you remember, one of your tests we did the match pair hypothesis testing, right? Match pair hypothesis testing. Uh, that's to see if there's, usually we use that to see if there's any difference between the sample, I mean the population mean, right? Of course, apparently here you see that the mean at the end of the semester is less than the mean for test 1, test 2. Okay, if I go back to, if we look at this thing here, if we look at this thing, you can see from here that the average for uh, final tends to be lower than the average of test 1, test 2, right? Okay, tends to be less. Okay, but still, can we say more than just simply saying, oh, at the end of the semester, your average will be less? No, that method that we had earlier does not work. So, give me a second. Oops, I need to do. Okay, so do you see my calculator and my note at the same time now? Yeah, I believe so. Okay, so what I'm about to do is not simply saying that there's a difference in the averages, but going further, if one individual have, let's say, average of test 1, test 2 is 60 in their test 1, test 2 on average, what can I say about what we expect this person to get at the end of the semester? So let's get the regression. Okay, how to get that regression? This is how you do it. After you occupy this from list 1 and list 2, I go to stats and go to calculate and go down here. LinReg, linear regression, AX plus B. Boom. Okay, now your X list is list 1. Let me change this to list 1. Your Y list is list 2. And then just calculate. Okay, now this is the 0.8965 that we have earlier. Oh, 5. I thought I have 6 earlier. My bad. Yeah, so this is what we have for the slope earlier, and this is the y-intercept. Okay, that's the slope and then the y-intercept. Now, how do we get the R, Thomas? It's actually something to do with the way I set up my calculator. Give me a second. Let me do this first. I think I need to go to variation, the y variance. Oh, no, 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 no. I need to go to mode. I need to go to mode and then go down further, 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 further. Go to the stats diagnostic, and then turn it on. Yeah, turn it on. So I go to mode again. I go to mode, go down to stat diagnostic, and then turn that on. This one here, stat diagnostic, turn that on. Okay. Now then you go back to that stats, calculate linear regression. So it will give you not only the slope and the y-intercept of that linear regression line, it also gives you the R squared and the R. Okay. I think, let me copy that down. This is the result we get from. This is the result we get from occupying L1 and L2. Okay, and then you go to stat, the stat button. Okay, and then from the stat button, you move the cursor to go to calculate and drag AX plus B. Okay, now that's what you will see. Then from there, we see that the y hat, not y though, so not y, not y. Okay, supposed to be y hat there. the y hat equals to 0.89650x plus, I'm sorry, minus 4.8248. Okay, and the r squared tells us the portion of y that can be explained by x, is resulted by x, and r is the regression coefficient. This is the regression coefficient. From the sample. So let me say sample regression coefficient. This also represent the strength of regression. Now you will see that R will be between -1 to 1, where R equals to 1 when the linear regression predicted, so both R equals to 1 and R equals to 1 will have the perfect prediction. Both of them perfect prediction. Perfectly or accurately. Okay, now the difference is if R is 1 means when X increases, the Y also increases. Okay, while when R is negative means they go opposite direction. When X increases, the Y decreases. Okay, now uh, suppose somebody then come to me saying, but Thomas, you know what? My average of test 1, test 2, let's say, so suppose somebody else come and to me and then say their average of test 1, test 2 is 60. What do we expect their final to be? Using the result from this last semester. Okay, using the result from this last semester, then I will use that number on and on the correct screen, right? Okay. Then I will use 0 point, and I don't need to use 5 decimal places actually. In reality, I can just use 0.896 if I want to. 60 minus 4.58248. I get y hat equals to 49.20752. I will tell that person to drop that. Yeah, because this person is at least 18 points away below the required minimum to pass the class. Okay, the required minimum to pass the class. I somehow wonder why my number is different. Yeah, my number here is a bit different from my number here. But I think it is possible that I typed something wrong in my list earlier. But don't worry about it. They get a very close number anyway. Or should I check? Let me check. Check. use that. And do I have any other different? Oh, oh, this one here. This one here. I typed 42.5 instead 42, supposed to be 42.25. Okay, I believe that's the difference. Okay, anyway, I will not correct that now. We get very similar result anyway. Now coming back here. So we see how we can use this to predict what somebody will get later on. We can use this also for example, if I have an SAT prep, right? And then I want to see if that SAT prep will be successful in training my children to increase their SAT score to the level that I want. Of course, if you go to SAT prep, we expect their SAT score to increase. But will that increase to the point that we want my child to have? Then I will ask, you know what, can you have past data? What are the SAT score students have when they first came to this SAT prep and what they get when they took the actual SAT test, okay, the actual SAT. Then from there, I compared it to the SAT for my son when starting that SAT prep, and hopefully we get what we need, okay? Or you can also use this for, suppose you want to manage your weight in sense of reducing your weight and you go to gym, for example. Then you ask the past data, you know what, your customers who started here, can I get the weight they have? And after 3 months, can I get the weight they have? And then you use the linear regression for those, okay? Let's see. I wonder if my internet is on. No, my internet is on, but let's get some linear regression data. And I ask you to do that. Linear regression example. Is there any? Oh, this one here. We can use this from. I think this is from Pennsylvania, Penn State. They don't give me the data. I need the data. Where's the data? Hmm? No, I need the data. I cannot do that. Hmm. How about this one? I hope this one. Yeah, this one. I hope this is. So let's say, for example, we use this. The diet score, compare that to the body mass index. Oh no, this is multivariable. No, I just want a single variable. Sorry. It's supposed to be. It's supposed to be. I want the data and I don't find the data right now. This is the program. So I basically show you how I get my examples too. So machine learning, data, type data. Will this work? Oh, this one is good. Okay, let me pick this one. Let me pick this one. And then put it in my node. Call that our new example. Call that our example. Now I want you to put this data into your list 1 and list 2. Okay, I'll give you 1 or 2 minutes for that. So this is the aptitude test. And this is the stats grade. Okay, let me get my calculator. I need to clean up first. So you do yours, I do mine. I will clear list 1 and list 1. List 1, 95 is the first one, 85 is the second one, 80 the third one, 70 the fourth one, 60 the last one. That's the aptitude test. And for each person, the corresponding scores, 85, then 95, and then 70, 65, 70. Okay. Again, let me look at the scatter plot. Oh, I didn't show you yet, huh? The scatter plot. You go to second plot on your calculator, and I will do plot 1, the first list and the second list. I will do the scatter plot. Turn it on, and then let me just use this plot. Okay, go. Graph. Oops. What happened? Go to zoom and zoom fit. Okay, what happened? Oh, now I know. Yeah. No, I cannot make this here. My minimum is 60. Let me make it 50 here, and the maximum here is 100. So my window is wrong. And then my y minimum, make it 60. My y maximum is 100. I hope this works right now. Yeah, that's what it looks like. Okay, so it seems like we do have some trend here. We do have some trend here. Okay, so you need to look at the scatter plot first and then feel it though, feel it. Do we have some trend? Well, you can actually get it right away also from the R later on. So let me just calculate and then go to linear regression. Line list one, list two, calculate. Oh, the R is very small, huh? The R is very, it's less than 70%. So this is actually not as strong as we would like that. So even though the aptitude test can predict the grade at the end of the semester, but it seems like it's not really a good one because it only explains approximately half of that. The other half is not being explained. That's the R. Let me screenshot that. Okay, so the R squared here is less than 50%. So the linear regression equation that we use here will not be as good. So y hat equals to 0.6438 4 x plus 26 something. Okay, unfortunately the R, the sample regression coefficient is 0.69305, which is not as good. Correlation, I think I should say sample correlation coefficient. Let me make sure I say it right. Yeah, so no, not regression, coefficient here. No, it's not regression. It's supposed to be correlation with double R. Okay, but suppose I insist to use this model, then let's say, for example, suppose somebody's aptitude test is, let's say, 72. Then what do you expect that person to get in his or her stat test? So that would be 0.64384 times 72 plus 26.78, blah, blah, blah. Okay, 0.64384 times 72 plus 26.78, blah, blah, blah. I will just round it to two decimal places. So y bar is 73.14 approximately. So notice that this R is actually not that strong. This R here is not that strong. Hypothesis testing. If you want to go further, which I don't plan to ask you this question, but I'm expecting you to use this in your real life. That's why I teach you some Excel earlier. Now, so hypothesis testing. Hypothesis testing on, is there linear correlation? between X and Y, the predictor and the predicted. Okay, can we use X to predict Y? And the formula will be the test statistic. So this is step 3. The test statistic will be, it's actually in our book, T equals to R over square root of 1 minus R squared over N minus 2. That's the test statistic. Okay, but then when we compute it, so this is in step 3. In step 4, the p-value, we will use the p-value will be two-tailed. Will be 2 times TCDF. Okay, and whatever we get there, comma, comma, and then, but the degree of freedom will be, 2 less than the sample size. Okay, 2 less than the sample size. Maybe I should say, what do we have in step 2, the hypothesis. The hypothesis will be null hypothesis, rho equals to 0. The alternate hypothesis is rho is not equal to 0. That's why then later on the p-value will be two-tailed. But again, I will not ask you the hypothesis testing case for linear correlation thing. Okay, this is only for your future use. If you ever need this though. Okay, I think that's what I want to teach you for this linear regression. You just need to find how to use the data. You just need to know how to use the data we have, how to plug it into your calculator, okay, and then how to get the equation of the regression line. What is the strength of the regression line, which is the R, by the way, which is the R. Sometimes I find the R. Sometimes I ask find the R square, but basically you look at your calculator. Okay, basically you look at your calculator here, right? So you need to know how to punch the data in, and you need to know how to get this result from your calculator. And then, of course, the last one is how to use that. To use the regression line to predict. Okay, in the last couple minutes, I would like to say the following. How far we can use this. Notice that we will get this prediction line, what we call regression line. How not to use this. We are not going to use regression line to predict something much further. Okay, I mean, if you are just like couple of points, let's say with the data we have here, if you're just couple of points above this 87, for example, yeah, you can use that. But if somebody get 100 in their test 1, test 2, can you say that something about their final average? Nothing much, okay, nothing much. Likewise, if it is way too low, nothing much. Okay, so be very careful that we do not extrapolate too far to the left or to the right of that line. The best one is to predict something in the middle of that line. So the data we use should be in between the data provided to us. Okay, like for example, if I have this number here, then do not use, for example, if somebody get 120 in the average for test 1, test 2. No, it doesn't work. Okay, Yeah, you can use anything in between, but not way too less or way too much. Okay. Second, be very careful with the fact that our data is too less. If, for example, we want to predict how cold, how warm it is uh, in December, you cannot use data from from July and August to predict what will happen in December. Because what? We know that the temperature is seasonal, right? It's cyclic. Okay, so be careful with that. So the the hypothesis of doing linear regression is actually quite strict in the sense that we need to be aware with a cyclic pattern. We need to be aware with that we don't extrapolate too much, okay, and be aware with the strength of our result, the R here, okay, and what part of uh, the portion of the actual value that we look for is predicted by our X value. Okay, I think that's where I want to stop. I don't want to go too far, but you need to know this. Okay, you need to know this. In my old test, I asked them to find the R by hand. Don't worry about that. You will just find the R by calculator. Let's see if I have that uh, in my old test. Give me a second. Let me see my 419. Do I have that in my final?
So Thomas, is there going to be class on next Friday, or are we just going to be doing the finals?
Just fine. Just fine. No class. And I will do my office hour at 8 to 9. Your test will start at 9 o'clock, not 8:30.
And we just need to finish it, submit the thing before 1:15, like the,
Yes. Yeah.
And do you think the linear regression we learned today will be make up like a good portion of the test, or just a minor portion?
Maybe like 10 points at most. 10 points at most.
What chapter do you think we should pay the most attention to in this case for the final?
Part 3. Confidence interval to hypothesis testing.
So just like the two previous tests we have, right?
I'm not saying that that's all though. I'm saying you asked me where you should focus, right?
Yeah.
Okay. So that's the claim. The claim is where should we focus, and my conclusion is we should focus on test 3, test 4.
For sure.
Okay. But I'm not in any way saying that that's all you need to study. No, not at all. Okay, not at all. Let me see further back. Because in the past I had the same question, and when I said it that way, and the students later on say that, but Thomas, your final is contains material other than what you say. I say that's what I say. That's what I say because that's. Wait.
And do you know approximately how many questions is going to be there?
Nope, I don't know. Because my question will be ABCD anyway, right? So I can tell you like 10 questions, but then it's ABCD.
For sure.
Right? Okay, I mean, it's my answer right now. If I say 10 questions, will that be different from if later on you find out to be 12 questions. I honestly don't think so, right? But you look at my old finals, the number of questions will not be too much more, will not be too much less. That's what I can promise you.
Yeah, because I felt like test 4 today was a little longer than other like the practice we had. So I was just wondering.
Actually, no. Actually, not that I know of. We know that test 4 will be a lot of writing. That's what we know.
Yeah.
Right? Yeah, well, because it's like you need to show that step 1, step 2, step 3 for the confidence interval, and then step 1, 2, 3, 4, 5, 6 for hypothesis testing. And then if you have 2 parameters, you still have this and that you need to show before you start the procedure. That's why I give you extra 1 hour.
Mm-hmm.
Right? Yeah, that's why I give you extra 1 hour. I don't really find a good one. Oh, I have this. Hold on. This one. Oh. Sorry for holding you a bit longer, but I want to show you this. The case that I showed you earlier. This is the actual number from even previous semester. So this was their test average of test 1, test 2, test 1 plus test 2 over 2. And let me see, this is the average right before final. Right before final. So everything including test 4, but before final. This is actually a better class, huh? To be honest with you, my stats class at East LA College is worse last semester and 2 semesters ago. So fall 19 is bad. The worst one is spring 19. That's the worst one. That's the worst one. But this is the first time they implement that AB 705. Is it right? AB 705? Yeah, AB 705, where there's no prerequisite for statistics class. Now, right before that, I have this data. Right before that, I have this data. So you see among those people who stay until the final, right? Only 1% actually in the position of not passing the class. This one also, but I will not tell this person to drop the class. I will not tell this person to drop the class. Why? Because average 60, however small the chance is, this person still have a chance to pass the class. This is the only students, maybe, I don't know if he or she forget to drop the class. But you see everybody else actually was passing, right? Yeah. And I have more students left. In this class right now, I think only 5 people left. Yeah, but I start with very, very bad number to start with. If I can show you the numbers, that will be quite surprising though. Yeah, that will be quite surprising. But anyway, this is what I have from even previous semester. Okay, this is the number I have from last semester. This is from fall 19. And this one is, so I'm talking about real data here. Let me see again which semester is that. Oh, this is from fall 2008. Yeah, this is from fall 2008, right before AB 705. Fall 2018. So, well, I hope you're doing fine, such that in your test 1 and test 2, such that you have some better confidence for your final. Okay. This is where I will stop my lesson.